Solve problems on dynamic force analysis or inertia force analysis on IC engine mechanism. Consider mass of connecting rod.
For dynamic force analysis of IC engine mechanism or slider crank mechanism, we have to consider the mass of connecting rod. And for the analysis of inertia effect of this connecting rod, we have to split the mass of connecting rod MC into two masses, that is M1 and M2. Now if we observe this diagram, this PC is the connecting rod. Now at this point P, connecting rod is attached to this piston and is known as the gudgeon pin. And at this point mass M1 is placed. And at this end C, this connecting rod is attached to this crank OC, and this point C is known as crank pin, and at this point mass M2 is placed. Now because of these masses placed arbitrarily at these 2 points, this system will become non-dynamically equivalent system, and for that we have to apply the correction couple. So how to apply the correction couple? So for that we will understand the difference in between dynamically equivalent system as well as non-dynamically equivalent system. So there are two masses that are placed and there is the center of gravity point, that is G. So we will show here for dynamically equivalent system, these are the two masses, then here is the center of gravity G, and from this point mass M1 is placed at a distance L1 and mass M2 is placed at a distance L2. Now the mass of connecting rod is equal to addition of these two masses. So MC is equal to M1 plus M2. Now the center of gravity of these two masses coincides with the center of gravity of the rigid body, or we can say connecting rod. So M1 L1 is equal to M2 L2. Now mass moment of inertia of these two masses is equal to mass moment of inertia of the rigid body. So this is the third condition is getting satisfied. So we can write here M1 L1 square plus M2 L2 square is equal to MC kg square. So if we solve this, then we will get kg square is equal to L1 L2. So this is the formula for the radius of gyration. That is, radius of gyration square is equal to L1 into L2. Now these all conditions are satisfied for dynamically equivalent system. Now we will move to the non-dynamically equivalent system. Now this system is same as this connecting rod because we have placed these masses M1 and M2 arbitrarily. So here this dynamically equivalent system is not getting satisfied. So if we observe, this is the center of gravity point G. So when this mass M1 is placed, we will say from this distance from G is L1. But mass M2 is arbitrarily placed, so here this condition is not getting satisfied. So we cannot take this distance L2, but we will take here the distance L3. And because this L2 we have not taken, and that's why this system is known as non-dynamically equivalent system. Now which conditions are satisfied? So for this system, mass of connecting rod is equal to addition of these two masses, that is M1 plus M2. Then the center of gravity of these two masses coincides with center of gravity of this connecting rod. So we can say that M1 L1 is equal to M2 L3. So first two conditions are satisfied, but the third condition is not getting satisfied. That is, the mass moment of inertia of these two masses is not equal to mass moment of inertia of the connecting rod. Now we will move for the formula, that is radius of gyration. So radius of gyration for non-dynamically equivalent system, we will take here kg1 square is equal to L1 L3. So this is the formula to calculate the radius of gyration for the non-dynamically equivalent system. Now we will apply the correction couple. So how to use the formula? So this formula is nothing but the difference in between torques for the non-dynamically equivalent system and dynamically equivalent system. So for non-dynamically equivalent system, torque required to accelerate rotate this connecting rod, that is T1, and for dynamically equivalent system we will take T. So the difference in between T1 and T is known as the correction couple, that is TC. So we have to show here in this diagram, we have to show this correction couple. So we can take any direction for this correction couple. That means we can take here clockwise direction or we can take here anti-clockwise direction. So I will show here this correction couple, that is I will take this upward direction force Fc, and here at this point C, because we have to apply this correction couple at this point P as well as point C, and at this point C I will take here the downward direction. So this Fc, if we apply, these forces are equal in magnitude but opposite in direction, and it is in clockwise direction. So this correction couple is applied, and that is the difference in between T1 minus T. So what is the torque T1 for non-dynamically equivalent system? So we have formula mc kg1 square alpha. Alpha is the angular acceleration. Then minus, now for dynamically equivalent system we have to take mc kg square alpha. So here mc and alpha we will take as a common, and kg1 square minus kg square. Then this is the formula to calculate the correction couple.
Given question, the piston diameter of an internal combustion engine is 125 mm and the stroke is 220 mm. The connecting rod is 4.5 times the crank length and has a mass of 50 kg. The mass of the reciprocating parts is 30 kg. The center of mass of connecting rod is 170 mm from the crank pin center, and the radius of gyration of an axis through the center of mass is 148 mm. The engine runs at 320 rpm. Find the magnitude and the direction of the inertia force and the corresponding torque on the crankshaft when the angle turned by the crank is 140 degree from the dead center.
Let us understand given data with the help of diagram. Diameter of piston D is given 125 mm, which is equal to 0.125 meter. Now the stroke length L 220 mm. So during the one stroke of this piston, there is the rotation of this crank from inner dead center to the outer dead center. So for one stroke length, the distance covered 2 times of this crank radius R. So we can say that L is equal to 2 times of R, that is 2R, and therefore R is equal to 0.11 meter. Now the one relation is given, length of the connecting rod is equal to 4.5 times of crank radius. So we know that obligatory ratio is L by R. So we can say that L is equal to 4.5. So from this relation we will also find out the value of L, that is the length of the connecting rod. So L is equal to 4.5 into 0.11, that is equal to 0.495 meter. Now the mass of connecting rod is given. So whenever the mass of connecting rod we have to consider, then we have to solve the question by dynamic force analysis. And when we split this mass of connecting rod, that is into two masses M1 and M2, and we have to place the mass M1 at this gudgeon point P and mass M2 at this crank pin D. Then the system will become non-dynamically equivalent system because we have to place these masses M1 and M2 arbitrarily. For this non-dynamically equivalent system, we have to apply the correction couple. So we can select any direction for these forces. So as the mass M1 is placed at this point P, so we have to apply here the correction couple, and I will select the direction of force in the upward direction. So here is the Fc. Now at the other end, that is at point D, we should select the opposite direction, that is in the downward direction. So I will show here the direction of Fc is in the downward direction. Now due to this correction couple, if we rotate in the direction of this Fc, then here is the clockwise direction. So what is the direction of the torque? That is the direction of the correction torque about this center of gravity point. So it is also in the clockwise direction, and I will show this with the help of the dotted line. So here is the TC. So this is the dot at this due to the correction couple. Now we will show here the mass m1. So mass m1 is placed at this point P and mass m2 is placed at this point D. Now reciprocating masses are also given, which is equal to 30 kg. Those reciprocating masses also acts at this point P. So what is the equivalent mass m1 plus mr? Now we know that weight always acts in vertically downward direction. So we have to multiply here with g. Now at this point D also weight always acts in vertically downward direction. So we can say that this is for m2g. Now the distance of the center of gravity point from this crank pin is mentioned. Now this distance is known as L3. So L3 is given 170 mm, which is equal to 0.17 meter. Now the radius of gyration for this connecting rod about center G is given. So for this connecting rod, if radius of gyration is mentioned, then this is for this equivalent, dynamically equivalent system. So we will say that the value of kg is given 0.148 mm, which is equal to 0.148 meter. Now n, that is the speed of the crank, is mentioned 320 rpm. So from that we can calculate the angular velocity, that is omega, 2 pi n by 60, which is equal to 33.51 radians per second. Now the angle theta is also given, it is 140 degree. So this is the angle made by this crank with this inner dead center. So we can say that this crank is rotating from this inner dead center towards the outer dead center. So where is the direction of rotation? That is in the clockwise direction. So we have to show the angle, so the direction for omega, that is angular velocity, that is in clockwise direction. So I will show here in the diagram. So this is shown by the given data, because it depends on where is the direction of rotation of this crank. So it is from inner dead center to the outer dead center. Now we will calculate what is the value of L1. So L is equal to L1 plus L3. So L3 is given, L is also we have calculated. So L1 is equal to 0.325 meter. Now we will calculate the masses m1 and m2 placed at the gudgeon pin as well as crank pin. So here is the formula. m1 is equal to mc, that is the mass of connecting rod, into L3 divided by L1 plus L3. So it is 17.1717 kilogram. Now we will calculate m2. So m2 is equal to mc into L1. So we have to take opposite side length. mc into L1 divided by L1 plus L3. So when we put the value, then we will get 32.8282 kilogram. As per the given data, crank rotate from inner dead center to the outer dead center. So we have to show here the direction of the piston force towards the right hand side direction. Now we have to calculate inertia force on the piston. So we know that the inertia force always acts in the opposite direction to the direction of the motion. So first we will calculate the inertia force on the piston, that is Fi. So what is the formula? That is equivalent to mass Me r omega square cos theta plus cos 2 theta by n. So why here equivalent mass is there? Because equivalent mass, that means this m1 plus mr. So we have to add these two masses and we have to take 30 plus 17.17. So this is the addition of the two masses is equivalent mass. So I will take here the bracket. In multiplied by r, 0.11 omega square 33.51 square cos of 140 plus cos of 2 into 140 by 4.5. So when we solve this, then we will get the negative answer, that is minus 4238.7475 Newton. So because of this minus sign, so where is the direction? So this inertia force always acts in the opposite direction, that is direction should be left hand side, but answer is in negative. So we have to show here the direction towards the same direction of the piston force. So I will show here the direction of Fi, that is in the same direction. Now we will move to the next parameter. We will calculate radius of gyration for non-dynamically equivalent system. So because we have splitted the masses into M1 and M2 and placed arbitrarily at this point P and D. So this system will become non-dynamically equivalent system. So how to find out the radius of gyration? So here we have to use the suffix 1. That is kg1 is equal to under root of L1 L3. So which is equal to under root of 0.325 to 0.17, which is equal to 0.235 meter. So this is the radius of gyration. Now we will calculate the torque exerted on this crankshaft due to inertia force. So here inertia force we have calculated, and now we have to find out what is the torque exerted on crankshaft due to this inertia force. So here is the formula. So this torque we will set T1 is equal to Fi, that is inertia force, into R in bracket sin theta plus sin of 2 theta divided by 2 under root of n square minus sin square theta. So we have to put the value. So this Fi is having negative sign, and we will put all the other values, and answer is minus 248.1591 Newton meter. Now if we observe what is the direction for this torque due to this inertia force. So it is always in the opposite direction to the direction of this crank or this omega. So here in this question omega is given in clockwise direction. So we have to show here anti-clockwise direction. So I will show, as per the rule we have to show this anti-clockwise direction. And for this anti-clockwise direction, this answer is negative. Now we will convert this answer into positive. So how to convert this? So I will write here, answer is 248.1591 Newton meter. Now because we have to multiply here with minus sign, we have to change the direction. So how to change the direction? We have to give here clockwise direction. So with this positive answer, what is the direction of this torque T1? That is the clockwise direction. Now we will calculate torque exerted on crankshaft due to correction couple. So this torque due to correction couple is Tc, and how to calculate this? We have formula mc into alpha in bracket kg1 square minus kg square. So mc is the mass of connecting rod, alpha is the angular acceleration of this connecting rod, and kg1, that is the radius of gyration for non-dynamically equivalent system, and kg, radius of gyration for the dynamically equivalent system. Now for this alpha we have formula, that is minus omega square sin theta by n. So we will put this formula and we will apply here the value. So if when we put all the values, then we will get the negative answer minus 267.2388 Newton meter. Now we know that for this torque due to correction couple, what is the direction? So direction mentioned here is clockwise direction, because this direction will depend upon the direction of these forces. So here we will show the same direction, that is the clockwise direction. Now we will convert this answer into positive. So how we will convert this? So instead of this minus, we will write here 267.2388. Now because of this plus sign, we have to change the direction. So direction we will show here the anti-clockwise direction. So for this answer. Now by using this value of Tc, we will calculate this torque T2. So what is this torque T2? So T2 is equal to Tc cos of theta divided by under root of n square minus sin square theta. So here we will put the value. So Tc is 267.2388 cos of 140 divided by under root of 4.5 square minus sin of 140 square. So when we solve this, we will get the negative answer, that is minus 45.9639 Newton meter. So how to decide the direction of this torque T2? So as same, we have decided the direction of torque T1, we have to show the direction of T2 in the opposite direction of this omega. So omega is having clockwise direction, so direction of T2 we have to show in anti-clockwise direction. But here T2 is having negative sign, so we will convert this into positive, that is 45.9639 Newton meter. So for this positive answer we have to again change the direction, so it's a direction we have to show in the clockwise direction. Now we will calculate torque exerted on the crankshaft at point O due to mass M2 located at this point D. So here weight M2G acts in the downward direction. So how to calculate the torque due to this weight M2G? So for that, if we observe, we have to take this weight multiplied by this perpendicular distance from this O. So we will make here one construction. I will draw here one line from this point O and up to this vertical line for this M2G, and at this point I will give here C. So how to calculate this? So torque T3 is equal to this M2G multiplied by this distance OC. So for this distance OC, how to calculate this? So we know this OD is R, that is the crank radius R, and here is the angle 180 minus theta. So here from this inner dead center to O and O to D, this angle is theta, so remaining angle is 180 minus theta. So in triangle DOC, OC is equal to R into cos of 180 minus theta. So I will write here formula M2G, and in bracket instead of OC I will write R into cos of 180 minus theta. So theta is 140. So I will write here M2G into R into cos of 180 minus 140, that is 40. So this is the formula that we have to use. Now when we put the value, that is M2 32.8282, G 9.8, R that is the crank radius 0.11, cos of 40, so which is equal to 27.137 Newton meter. Now how to decide the direction? So with the help of compass, if I place here this point O and I will move the compass in the direction of weight, then here is the clockwise direction. Now we will calculate the torque, and that is nothing but the addition of torque T1 plus T2 plus T3. Now T1 and T2 are also in clockwise direction and T3 is also in clockwise direction. So answer is 321.26 Newton meter, and for this direction is clockwise.
Given question, a single cylinder horizontal steam engine has a stroke of 0.75 meter and a connecting rod 1.8 meter long. The mass of reciprocating parts is 520 kg and that of the connecting rod is 230 kg. Center of gravity of the connecting rod is 0.8 meter from the crank pin, and the moment of inertia about an axis through the center of gravity perpendicular to the plane of motion is 100 kg meter square. For an engine speed of 90 rpm and a crank position of 45 degree from inner dead center, determine the torque on the crankshaft due to inertia of the parts by analytical method.
Let us understand the given data with the help of diagram. If we observe the question, mass of connecting rod is mentioned in the question. So whenever this mass of connecting rod is mentioned, that means we have to solve this question by using the dynamic force analysis for the slider crank mechanism. Now the stroke length is given 0.75 meter. So here is the piston, and for this piston one stroke is getting completed when this crank rotates from this inner dead center to the outer dead center. So we can say that stroke length is equal to 2 multiplied by this crank radius r. So how to calculate r? R is equal to 0.75 divided by 2, which is equal to 0.375 meter. Then the connecting rod length L is given. So from this P to C is the connecting rod length L, 1.8 meter. Then the mass of reciprocating parts is mentioned 520 kilogram. So at this piston there is the mass of reciprocating parts. So we have to mention at this point P there is M into R. Then the mass of connecting rod is given 230 kilogram. Then the distance from the center of gravity of this connecting rod to the crank pin, that is the distance C to G, is mentioned, and that is equal to 0.8 meter. So if the mass of connecting rod is mentioned, that means we have to solve the question by dynamic force analysis, and we have to split this mass MC into two masses, that is M1 and M2. So this mass M1 we have to place at this gudgeon pin P. So here we have to mention this mass M1, and we have to place this mass M2 at the crank pin C. So we have to mention here mass M2. So the distance from the center of gravity to this point C is nothing but L3, because this is non-dynamically equivalent system. So I will show here L3, and this distance L3 is also given, and that is 0.8 meter. Then moment of inertia about the center of gravity is also mentioned. So this moment of inertia 100 kilogram meter square. Then the engine speed N is given 90 rpm. So from this N we can calculate the omega. Omega, that is the angular velocity of this crank. So 2 pi n by 60, that is 2 pi 90 by 60, which is equal to 9.424 radians per second. Now the angle theta is also mentioned. So how we can define this angle theta? That is the rotation of this crank from this inner dead center. So from this inner dead center, this angle is given as a theta, and which is equal to 45 degree. Now from this given angle, that is as the crank rotates from this inner dead center to the outer dead center, then the piston will move towards the right hand side. So we have to show here the piston force, that is I will show towards the right hand side. So from this angle theta we can conclude that F is acting towards the right hand side direction. Now we will calculate the obligatory ratio N. So N is equal to L by R, that is this ratio of L by R. So R is calculated, so 1.8 divided by 0.375 is equal to 4.8. Now L and L3 is known, so we can calculate L1. So L1 is equal to L minus L3. So here I will mention L1. So L1 is equal to 1 meter. Now we will calculate the masses which are placed at this gudgeon pin as well as crank pin. So there is the formula, and with the help of formula we can calculate this. M1 is equal to, so this M1 is equal to MC into L3. So we have to take the opposite side length. MC, that is the mass of connecting rod, into L3 divided by L1 plus L3. So we have to put the values, and we will get the answer 102.22 kilogram. Now mass M2. So for this mass M2 we have to take M2 is equal to MC into L1 divided by L1 plus L3. So when we put the value, then we will get the answer 127.77 kilogram. Now if we observe this diagram, then at this point P there are two masses, that is mass M1 as well as mass MR, that is the reciprocating parts. So weight always acts in vertically downward direction. So in the downward direction we have to show weight. And what is this weight? That is mass into G, mg, that is m1 plus mr into g. Now in the same way, at this point C, the weight always acts in vertically downward direction, and we have to show here m2 into g. So this is the weight that we have to show. Now we will calculate inertia force of the piston. So we know that piston force is acting towards the right hand side direction and the no gaseous forces are mentioned in the question. So inertia force is equal and opposite to this piston force. So I will show the direction towards left hand side for this Fi. So how to calculate this? Me, that is the effective mass, r omega square cos theta plus cos of 2 theta by n. Now here Me effective mass at this point P, how to calculate? So mass M1 is there as well as mass of reciprocating part. So M1 plus Mr is Me. And when we calculate, we get 622.22 kilogram into 0.375 into 9.424 square in bracket cos of 45 plus cos of 2 into 40 by 45 by 4.8. So n is the obligate ratio. Now when we calculate this, then we will get inertia force 14,653.19 Newton. Now we will calculate the radius of gyration for the dynamically equivalent system as well as non-dynamically equivalent system, because we have to take the difference to calculate the correction couple. So here how to calculate the dynamically equivalent system? So here for this connecting rod, moment of inertia about the center of gravity G is mentioned in the question, that is Ig. So Ig is equal to mc into kg square. So kg is the radius of gyration for the dynamically equivalent system. So 100 is equal to 230 kg square and kg is equal to 0.6593 meter. Now non-dynamically equivalent system. Now if we observe these masses M1 and M2 placed arbitrarily at this gudgeon pin as well as crank pin, and that's why this system is known as non-dynamically equivalent system. So what is the rule? So we know the distance from the center of gravity for this point P as well as point C, that is L1 and L3. So we calculate here kg1 square is equal to L1 L3. So kg is equal to under root of L1 L3 and which is equal to, so when we put the value we will get 0.8944 meter. Now we will calculate torque exerted on crankshaft due to inertia force Fi. So this torque is called as T1. So what is the formula? So which is equal to Fi into R in bracket sin theta plus sin of 2 theta divided by 2 under root of n square minus sin square theta. Now we will put the value. So Fi that we have already calculated, then R 0.375 sin of 45 plus sin of 2 into 45 divided by 2 under root of n, that is 4.8 square minus sin theta square, that is sin of 45 square. So when we calculate this, then we will get the answer 4464.217 Newton meter. Now how to decide the direction for this torque T1? Now if we observe here, the crank rotates from this inner dead center to the point C, that is the direction of angular velocity in this clockwise direction. So we can say that this direction of omega we have to show in clockwise direction. So when this is in clockwise direction, then we have to show the direction for this T1 in opposite direction, that is in anti-clockwise direction. So here is the direction. Now we will move to the next. Torque exerted on crankshaft due to correction couple. So for that we have to first calculate correction couple. So this Tc is equal to mc into alpha kg1 square minus kg square. So this is the formula. So mc, that is the mass of connecting rod, alpha angular acceleration alpha. So what is the angular acceleration for this connecting rod? So for that we have formula. In previous video we have seen the formula to calculate this alpha, that is minus omega square sin theta divided by n. So and in bracket kg1 square minus kg square. So we have calculated this. So when we put the value, that is mc 230 minus omega square minus 9.424 square into sin of 45 divided by n 4.8 in bracket kg1, that is 0.8944 square minus 0.6593 square. Now when we solve this, then we will get the answer minus 1099.162 Newton meter. Now what is the direction? So direction for this TC, that is this torque of the correction couple. So this correction couple is in clockwise direction. So we will show here the clockwise direction. But now if we want to cancel this negative sign, then we can write this in the other way. That is, I will write here the answer, that is TC is 1099.162, and because we have cancelled this negative sign, so we have to change the direction, that is in anti-clockwise direction. Now we will calculate T2. So T2 is equal to TC cos of theta divided by under root of n square minus sin square theta. So when we put the value, then we will get the answer 163.707 Newton meter. So how to decide the direction for this torque T2? So here, as this direction of this omega is in clockwise direction, so direction of T2 we have to mention here in the opposite direction, that is in anti-clockwise direction. So if we observe, the direction of T1 and T2 will depend on the direction of the omega. So when it is in clockwise direction, we have to show the opposite direction, and when it is in anti-clockwise direction, then we have to give here the direction that is the opposite, that means clockwise direction. Now we will calculate torque exerted on crankshaft due to mass M2 placed at this crank pin. So here mass M2 is placed, so weight M2G is acting in the downward direction. So what is the formula? So T3 is equal to this M2G into R into cos of theta. So here 127.77 into 9.81 into 0.375 into cos of 45. So what is the answer? 332.382 Newton meter. So how to decide its a direction? Now we will use this compass. So I will place here this at point O, and I will move the compass in the direction of M2G. So about this point O, if I move the compass that is in the downward direction, then the direction is anti-clockwise direction. So we have to show here the direction anti-clockwise. Now we will calculate the total torque T. So T is equal to T1 plus T2 plus T3. Now if we observe, T1 is in anti-clockwise direction, T2 is also in anti-clockwise direction, and T3 is also in anti-clockwise direction. So we have to add all these torques, and when we add this, then T is equal to 4960.306 Newton meter, and its direction is also anti-clockwise.